Hello, good morning. Today we will discuss about information sources and extension of discrete memoryless source. Here, information source. What is the information source? It is an object or source that produce an event, the outcome of which is selected at random according to the probability distribution. A practical source in a communication system is a device that produces messages. Means it produces messages according to the information. Messages are two types. First is analog and second is digital. Analog means amplitude change with respect to time is continuous. Means it different time it gave different amplitude. Second is digital or discrete, means amplitude of signal change with respect to time is discrete, means for some time they have fixed amplitude and we use always digital. So first we convert into digital. Analog to digital conversion by sampling theorem or quantization technique, because digital give extra advantage with respect to analog. First thing, error detection techniques. We can detect the error in digital. So sampling and quantization technique we read in communication system in previous classes. Here, discrete memory information source. Discrete information source is a source that has only a finite set of symbols as possible output. Set of symbol is called source alphabets. The element of sets are called symbol or letters. Information source can be classified as memory and memoryless source. A source with memory is one for which a current symbol depends on previous symbol. What? A memoryless source is one for which each symbol produces independent of previous symbol. Means it has no memory with respect to previous symbol. Here, discrete memoryless source. It is the combination of discrete and memoryless, means it has digital signal and it not depend the previous signal. So discrete memoryless source can be characterized by the list of symbol, the probability assignment these symbol, and the specification of rate of generating these symbol by the source. So here we discuss the extension of discrete memoryless source. Consider the discrete memoryless source having alphabets x is equal to x1, x2, x3, m. This source emit m number of individual symbols. The symbol of this alphabet can occur in group of two or more. These group of symbol can be said to be produced from extended source. This extended source is said to be have x की power n alphabet with m की power n distancing symbol. Here n is the number of successive symbol in one group or blocks. The symbols generated by discrete memoryless source are statically independent. So probability of group of symbol is obtained by product of individual symbol probability, entropy of xn and xh is related x bracket x की power n is equal to n into hx. So we can understand extension of discrete memoryless source by a example. Here a memory, a zero memory source means memoryless contain four symbols x1, x2, x3, x4 with probability 1 upon 2, 1 by 4, 1 upon 8 or 1 by 8. So first thing, determine the entropy of source, and second, determine second extension of source so that h x square is equal to 2hx. So first, to obtain entropy hx is equal to the entropy of single probability hx is equal to p1 log base 2 1 upon p1, and here 4 probability and 4 symbols, so we can write simply p2 log 1 upon p2 plus p3 log 1 upon p3 plus p4 log 1 upon p4. Put all the values and answer is hx is equal to 7 upon 4 bit per symbol. Second thing, source alphabet x contain 4 symbol. Here the second order extension. Second order extension means all symbol create with another symbol. Here we use x1, x2, x3 and x4. Here second order extension x1 multiplication with x1, x1 multiplication plus x2, x1, x3, x1 and x4. Again x2, x2, x1, x2, 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 x3, x2 and x4. x3, x3, x1, x3, x2, x3, 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 x4 and x4 again x1, x4, x2, x4, x3, x4 and x4. The probability of symbol we can simply multiply x1 and x2 is 1 upon 2 multiplied by 1 upon 2 is equal to 1 upon 4 and so on. X1 x2 is 1 upon 2 into 1 upon 4 is 1 upon 8. So here p sigma is equal to 1 upon 16, 1 upon 16 so on and up to 1 upon 64 is last serial number 16. Here the entropy of combination of two symbol is 1 upon p log base 2 1 upon p. Put the 1 upon 4 as p is 1 upon 4 log base 2 4 is equal to 1 by 2. And next x2 and x1 and x2 probability combination of 2 is 3 upon 4 and 1 upon 4 1 upon 4 3 upon 8 1 upon 4 5 upon 32 5 upon 32 1 upon 4 5 upon 32 6 upon 64 6 upon 64 1 upon 4 5 upon 32 6 upon 64 and 6 upon 64. So here the combination of x4 and x4 is probability is 1 upon 16 and entropy is 6 upon 64. The entropy of second order extension of source can be obtained simply h x square, means combination of two symbols is summation of I is equal to 1 and up to 60 p for combination of two labels log base 2 1 upon pi, put all the value, then add 1 upon 2 plus 3 upon 8 plus 1 upon 4 plus 1 upon 4 plus 3 upon 8 plus 1 upon 4 plus 5 upon 32 plus 5 upon 32 plus 1 upon 4 plus 5 upon 32 plus 6 upon 64 plus 6 upon 64 plus 1 upon 4 plus 5 upon 32 plus 6 upon 64 plus 6 upon 64. And total answer is entropy is 7 upon 2 bits per symbol. It is the extension. Observe here hx is 7 upon 4 but h x square is 7 upon 2, means h x square is equal to 2 into hx. Simply put the value of hx, it is equal to 7 upon 2, means we use two label extension of source. The entropy of two label is double. If we use three label of extension source, entropy is triple. So thank you very much. It is very interesting for student because